Hello guys, this is FK from Landcasts, and in this AI dictionary video, we're going to be defining vector stores. So what are vector stores? Embeddings, and if you're still trying to understand what embeddings are all about, you would want to check out our video on embeddings. So we know that embeddings are numerical ways to represent items. So let's say we have a picture of a dog, an image of a dog. Then we run it through an embedding process. It's a very short arrow. I need a longer one. So we run it through an embedding process, and we get this matrix representation of what the picture represents. 0.3, 0.5. So we get an embedding. We get a vector representation of what this image represents, which is a dog. Yeah, so we know there's a dog in this image. Based on so many features that have been defined, we get this embedding representation. So we know that. Now, once we have these embeddings, we need a place to store them. And in comes vector stores or vector databases. Vector stores or vector databases, this is where we store our embeddings, because we would want to search these embeddings, we will want to query them. So we store them inside vector stores. So that's what vector stores are all about. Storing embeddings. You can stop the video right now. That's all vector stores are all about. But let us look at how vector stores operate. Now, vector stores are basically a database. They are a database. But instead of your regular database, now let's have a regular database here. So let's say regular database, and let's have vector DB. So our regular database, like our MySQLs, our MS SQLs, and Oracle, they're like a library that stores information based on, let's say, authors, titles. So they have a card catalog where you can search books by authors, you can search them by titles, or you can even search them by publishers. You can search them by authors, by titles, by publishers. However, our vector databases, they store items based on mood. They store items based on meaning. They store items based on vibe. Yeah, store items based on vibe. So what you see in a vector database, instead of grouping books together by authors, or grouping them together by titles or by publishers, they are grouped by, let's say, love and romance. Action trailers. Fiction. Yeah. Vector database, they group items based on how related they are to each other. Yeah, that's how vector database group items together. That's how they store items. And this makes it very easy for you to search stuff. It makes it easy for you to search stuff. You can run a query. You can run a query into a vector database and say, I need a girlfriend. Say, I need a girlfriend. Run a query into a vector database saying, I need a girlfriend. Now, note, you didn't say anything about love. You didn't say anything about love? Nope. You didn't say anything about love or romance. Or at least you didn't say it exactly. You didn't say the exact words. But then you get, let's say there are books in this database and there are movies. You start getting different love novels. Start getting different love novels. Need my eraser again. So you start getting love novels. You get love movies, romantic movies. Yeah, you get romantic movies and all that. So you didn't specifically mention love. You didn't say love. You didn't say romance. You just said, I need a girlfriend. And automatically it's going to be able to understand what this statement represents the semantic meaning of the statement and recommend love novels, romantic movies. Let's say it contains movies and novels. It is going to recommend these things for you. Now, what this means is that vector databases don't use keywords. Unlike regular databases, they don't search by keywords. Like I said, they search based on meaning. They search based on vibe, based on mood. So that is the big difference between regular databases and vector databases. Now, this has made vector databases to be very, very useful for a couple of things. Let us look at what they have been useful for and why they have been really powering this whole LLM AI trend that we are currently experiencing. So the very first big application is in building recommendation systems. Recommendation systems. Like I said, they store items based on meaning, and they make sure that things that have similar meanings are grouped together. So a service like Netflix gets to use a vector database, and they store their movies, they convert them to embeddings, and they store their movies there. And when you pick a category, let's say romance and stuff, they can go in and search a bunch of romantic movies for you on Netflix. They just filter everything and they search. The titles don't need to sound romantic. The description doesn't need to sound romantic. All the characteristics of the movie has been computed into embeddings, and now they can recommend it to you for your romantic session. Now, the second is semantic search. Semantic search, which is also in the area of finding things based on meaning. Whenever let's say you tell an LLM like a chatbot like ChatGPT, you tell it to write you a sad poem. You just say write a sad poem. It's able to go into its knowledge base and then craft a poem with probably a storyline or different words and punchlines that evoke sadness. Or you tell it, probably you put a bunch of poems into the database and you just search for sad. It's going to go into that database and search based on the construct of all these poems. It's going to extract the poems that evoke a sad emotion. So semantic search. Another major thing is image recognition. Image recognition. It really shines in this. Image recognition. So because embeddings have been computed with features, and these features define the meaning of things, it's very, very easy for vector databases to know related pictures, to know pictures that relate to each other, to know items that relate to each other inside pictures. Now, a very good example of this. So here we said Netflix. So Netflix was a very good example of it. Netflix. And here I mentioned poems. Yeah, like poetic stuff. How you can just say sad and it will just go into a poetic database and extract poems that evoke sad emotions. Image recognitions. Think Google Photos. If you're using an Android, and I'm sure that iPhones have an equivalent, if you're using an Android, you can go into your Google Photos and you see it has automatically grouped some pictures for you. Pictures of yourself, pictures of your friends, pictures of some members of your family. You'll see an icon. It just has this icon. It shows them like this in like circles. So it will preview your face here, preview the face of a friend here, preview some guy you met at the park and somehow snapped a lot of pictures with. So, and when you click that particular circle, like this is me, this is friend, this random guy. If you click me, it's going to bring out all my pictures because it's able to recognize how I look like based on how the embeddings have been constructed. If you click my friend, it's going to bring out all the pictures of my friend and all the pictures that we snapped together. And same thing for random guy or random girl. So embeddings shine in representing these items, and vector stores are where we store those embeddings, and they can help us with retrieval. They can easily help us with retrieval because things are grouped based on how they match, how they relate to each other, the emotions that they evoke, and just a simple query into a vector database is going to be able to extract what is relating to our query, even if we don't use keywords that match those things, because things are stored in vector databases based on meaning. And that's why they are very popular in RAG. Vector databases are a key component in RAG. Retrieval augmented generation, they're a key component. By the way, we have a RAG video. If you're watching this video and we've not released it yet, that was most likely the video we're going to release next. But if we've already released it, you can check the channel for it. Lucky you, it's already there. So yeah, that's why vector databases are a very important component of RAG. And that is vector stores and vector databases.